Everyone, I'm going to talk about completing the square. Okay, so with our quadratics, what we're given is we're given, for instance, something that can be complex. And in mathematics, what you always do is you take something complex and you rewrite it in a simpler form. And we can go all the way to whenever we dealt with just something simple like x minus 2 equals 4. And by our rearrangement, what we do, we end up with x equals 6. Okay? In all of your problems in math, it's almost like a funnel. You start off with something bigger, and as you work through, you end up with something smaller. You keep channeling it. You write something in a more simpler fashion. We do that with our lives. We like to take things that are complex and disorganized, and we like to structure them and make them more organized. It's peaceful. Mathematics is still the same way. So, with what we're doing with these types of problems, is that we're factoring them. And factoring is simply finding the two numbers, we'll call them, that multiply together to give us what we're looking at. Very simplistic, but if I just looked at, let's say, 36, and I said, what are the factors of 36? Then you could go along and you could be able to list out certain factors. I mean, like we could have 6 and 6, and 4 and 9, and 2 and 18. Okay, we could come up with different sets of factors. With our quadratic, that's what we're doing because we've taken a more complex number and broken it down into smaller numbers. And that's what we're doing. But sometimes the quadratics that we have just aren't that simple to uh, be able to see what we can factor it into, be able to rewrite our binomials simply. So there is one process called completing the squares. And with completing the square, just some quadratics cannot be factored evenly in the form that they're written. So with any equation, we're not going to do something to one side and not do it to the other. But what we're going to do is we're going to create it to where we make a perfect square in what we're looking at. So let's actually look at our example here. Ax squared plus bx plus c equals 0. Okay, to use completing the square, a must equal 1. So your problem is simply going to be x squared plus bx plus c. First thing to do, isolate c. C is your constant term. Again, c is your y-intercept. Whatever that value of c is, that is going to be your y-intercept for any of your graphs, quadratics, linear, cubic. So I'm going to isolate c, meaning I'm going to get c by itself. So I subtract c from both sides. So this is what I'm left with, x squared plus bx equals c. To complete the square, what I do is I take the value of b, I divide it by 2, and I'm going to square that. And then I'm going to add it to both sides. I just can't add it to one side. I have to do it to both sides. We've done that whenever we were solving equations. We do that with fractions. You just can't do something to the denominator without doing it to the numerator. So I'm going to add that to both sides. The left portion is now a perfect square. This is my left portion right here. The left portion is now a perfect square. Rewrite as a square of the binomial. So I can simply take this value without it being squared, x, and this value, b divided by 2 without it being squared, put it into a set of parentheses, plus sign in between them, and write a squared value there. Equals, and there's nothing that I can do with this other than to simplify, to solve. And then from there, what I will use is the principle of square roots to solve for x. So this is the basic premise of completing the square. Very briefly, first thing to do is to make sure that a does not equal any other value besides 1. Next, isolate c. Then I'm going to take b and I'm going to divide it by 2 and square it. And I'm going to add it to both sides of the equation. and then I simply take the unsquared version of these two values, put them in there and square them. If I actually write this out, x plus b divided by 2 times x plus b divided by 2, this is what I get. This right here is written as a perfect square. Written as a perfect square. This is the factoring of a perfect square. Okay, so let's see that with an actual problem. In our problem, what we're going to do is we're going to complete the square of the given equation. Alright, so given the equation x squared plus 6x minus 7 equals 0. If you notice, my value of a is 1. It's just not written there. So I'm good. Now I need to isolate c, the constant term. I do that by adding 7 to both sides. So I end up with x squared plus 6x equals 7. Now I'm going to complete the square. I say 6 divided by 2 squared, that is b divided by 2 squared. In this case, 6 is the value of b, and I add it to both sides. Now, notice I don't leave it as 6 divided by 2. I go ahead and simplify that fraction, but I don't worry about the square. I now rewrite the left-hand portion, or the left side, as a perfect square. X plus 2, and I square it. Over here on the right hand side of the equation, all I did was simplify. I said 7 plus 3 squared, 7 plus 9, 16. For where we're at here, how to solve this is what we learned in the last video. Use the principle of square roots. Take the square root of both sides. I'm looking for the principal square root. So x plus 3 equals plus or minus 4. And I solve. I say x plus 3 equals a negative 4 and x plus 3 equals 4. My values, negative 7 and 1. I have two real number solutions. Let's look at that graphically. Negative 7 is my y-intercept. See that? See, negative 7, that's the constant term. That's always going to be your y-intercept. And then I have my values that I found as solutions, a negative 7 and a 1. Again, this is Desmos, DESMOS.com. It is a very good tool to use. Okay, so for the rest of the video, go ahead and pause the video, and I want you to see if you can factor this by completing the square. Alright, I can't factor this quadratic in its current form because my products, the factors that will give me 25 are 1 and 25 and 5 and 5, or a negative 5, and a negative 1 and a negative 25. These four sets, because a negative times a negative is a positive, it's plus 25. These four sets, I cannot take the sum of those and end up with 8. I cannot take the sums of those and end up with 8. So I can't factor in its current form. So what I'm going to do is I'm going to complete the square. My a value is 1. So what I have here is x squared plus 8x. And I'm going to go ahead and move my constant over. I subtract 25 from both sides. And then what I'm going to do is do b, which is 8. I'll write this over here. B equals 8. So therefore I have b divided by 2 squared. Therefore 8 divided by 2 squared, which is simply 4 squared. So I'm going to add 4 squared both sides. x plus 4 squared, and I'm going to work that out, equals, well, this is a negative 25 plus 16. Again, real quick, x plus 4 times x plus 4. That's what this says, right? So x times x is x squared, x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16. What I have is x squared plus 8x plus 16. And what is 16? Just simply 4 squared. So if you look at this, what I have here, and none of this is what you have to do, I'm just showing you how what I have right here, x plus 4 squared equals, is the same as this. If you look at that, this is it. All I've done is rewritten it. Okay, all I've done is rewritten it. Goes back to that example. If I said, okay, I could write 36, or I could write 6 times 6. It's both the same thing. So back to what we were doing here, I'll rewrite it again. That was our sidebar, equals, and this one right here is a negative 9. Principal of square roots. So I take the square root of both sides. Principal of square roots. So that results in x plus 4 equals the square root of a negative 9. And we remember I equals the square root of a negative 1. So I'm pulling out an I. I have x plus 4 equals, and here I'll write this over here, I have a negative 1 and the square root of 9. That becomes I, the square root of 9 becomes 3. So plus or minus 3i. So that is x plus 4. Whoops. Let me go ahead and do that. I'm going to subtract 4 from both sides into what I'm doing. Well, no, I'll just write it out like that. X plus 4 equals a negative 3i, and x plus 4 equals 3i. So what are my solutions? X equals a negative 4 minus 3i, and negative 4 plus 3i. Those are my solutions. Okay, so real quick, for completing the square, what we're looking at is a needs to be equal to 1. I move the constant by itself. What I do to one side, I have to do to both. And then I take the value of b, I divide it by 2, and then I write it as a square. I add that to both sides. So I've added it to both sides. I solve the fraction if I can. And then I simply take the value of what is x plus whatever this fraction equivalent is. And then I write it as a binomial and I square it. It's a perfect square of that quadratic. And then on the right hand side, I just simply do the math and solve. Okay guys, structure your problems. Critically think about what you're doing. Watch the publisher's videos, and good luck on your homework.